I mean, that's something that yeah, like what's dodge? I can not dodge.
What is especially?
Like I mixed it. I mixed it. What does that have to do?
Weak and strong word.
Yeah, I think this is restroom. Yeah, solution. But it is solution or mixed.
Okay, so we're just gonna continue with our packet.
I think I'm not saying.
What was the last problem that we left off?
Nine. I didn't.
9, okay.
Oh,
Yeah, sorry.
okay, so M1, M2, I mean, M1, was that, M1, keyboard and stuff. That's the ball. Wait, the little things I do have more. I'm gonna. If I'm doing the morality.
Okay, so 27 to the 4/3, you know, you rewrite as a radical form. Over to root. On 27, we do that first, that becomes 3. And 3 to the 4th power is 81. Okay, so number 10. 8 to the negative 2/3. We know the negative exponent means the base is going to be flipped to the other side. So that 8 gets pushed down to the bottom. There's still a 1 remaining up top. 8 to the 2/3, that's same thing as the cube root of 8 squared. Take care of the cube root of 8, make that number smaller. And 2 to the second power is 4 and 1. Yeah.
Could you, like, ignore the negative until the last step?
You could, yeah. Yeah, you could. Okay, does everybody have this packet? All right, number 11. Now, when you're solving an equation that has the same base, you can just cancel them out and just look at the exponent. So here, the bases are the same. I just focus my attention on setting the exponents equal to each other.
I have a question about that.
Yeah.
So like, could you like, what I was thinking about doing before is like dividing the 10 by the 10 and then subtracting the do like exponents.
Um,
So then when you divide, you subtract exponents.
let's see, if we do that, you divided both sides by the 10 to the 4th.
Yeah, so it'd be, and so it'd be like 4x plus 3 minus 2x minus 2. That works.
That should work. But then there's gonna be a 1 left on the other side. Let me see. Hmm. Let's see, 8 to the 1. Yeah, let me come back to you on that. I think it does feel like it should work, because if I divided both sides by that 10, it should be equal to 1. Okay, so the issue is that, yes, you're right, it would clean up if you do that, but here's the problem. This is what you did, right? You divided both sides.
Yeah.
So this becomes 1, but then you're left with 10 to the 4x plus 3 minus 2x plus 23 equals to 1. You can solve it this way, but then the bases don't match. You got to do natural log. You got to involve exponential. So you can solve it this way. We'll talk about that later. But the bases are the same. That could clean up our process a lot faster. Okay, number 11. I'm sorry, number 12. So we can set the exponents equal to each other if the bases are the same, but they're not quite the same. So the way we can do this is we can take the larger base and force it to be a smaller number. Now 9 can be represented as 3 raised to the what power? Second, right? So I'm just replacing that 9 with 3 squared, but everything else I'm going to leave alone. Once I replace that 9 with 3 squared, now the bases match. I can remove the bases and just focus on my exponents. Make sure you distribute that 2 through. It's really a 1. Subtract 2x from both sides. Negative 1x equals negative 4. Okay, 13. 25 and 125 are related. But I can't quite force that 125 to be 25 raised to a power, at least not to a integer power. So I may want to work on both sides to get it down to a number that they both share. So 25 and 125, they both share 5, right? So 25 can be represented as 5 what? Squared. Keep your original exponents. 125 can represent it as 5 to the third, then keep your original exponent. Now that the 5s match, just focus on my exponents and solve for x. Distribute the 2 through. Four x minus 3x was 1x. 12 plus 8 is 1. Okay. All right, so go ahead and start page 3. Work through those problems. I'll show the answers as you guys get through, and if we have time at the end, we can start 10.02 as well. I like to be slightly ahead so that we can just gain some more practice and review days. So just to let you know, there are a number of ways that you can clean this up. As long as you're following the rules accordingly, we may have different steps cleaning up, but at the end, we should all match. So remember, when you are multiplying bases, you're adding exponents, but when you have a base and the base next to each other, that's when you multiply. Okay, so go ahead and start number 1. And I'll work through the same times you guys are working through as well.
What are, has to be calculated?
Um. Let me get back to you on that. Let me look. No calculator. You can leave your answer and simplify without a calculator, but yeah, this has been no calculator. Are we okay? 1, 2, and 3.
Could you explain the two?
So, I merged all the numerators together, the 2x, the y cube, I'm adding exponents, so that becomes y to the 6th.
How is it two X after the top? Is it just but the coefficient part?
That's right, yeah, I just moved it, yeah.
How did you get 3?
Uh,
The -4 only go to the A?
It goes to the 2 as well. So it's 2 cubed, a to the -12.
And then you,
And then I just flip-flopped them. I put that a to the 4th below, I moved that a to the 12th above, and then I just subtracted. There's 12 a's above, 4 a's below, so when I cancel 4 of them out, I still have 8 left up top.
Okay, so for number 2, you just like add, like, take away the reason, add everything up and like put it in order.
Yeah, I put it in
order. Okay.
Good. Any other questions? What could do? Right, number 4, 5, and 6 are similar to what we saw before. We're gonna force the bases to be the same so that we can just focus on the exponents. Okay, so 4, I only have to worry about the left side, getting that 27 down to the 3. But number 5, 4 raised to an integer power doesn't quite get to 8, so I'm going to force them both down to a base 2. 8 is 2 to the 3rd power, 4 is 2 to the 2nd power. Once I get the bases to match, move the bases, it's focus on my exponent. Okay, so number 6, I'm just combining my terms here. 3 to the x squared equals 1. Now, I don't see a common base here, but maybe I can force this right side to be what? 3 raised to what power? Let's see what it was.
0.
0, yeah. 3 to 0 equals 1. The bases can go away, so focus on the exponents. X squared equals 0, x is 0. Number 7, feels a little messier, but if I can get all the bases to match, then I'm able to make some progress. So 16, 64, 64, they all can share a base 4. Now, if I'm multiplying bases, what do I do with the exponents? Add, yeah, add them, add them. Now that I can clean up that left side, I can drop the bases and set the exponents equal to each other.
You multiply the fours.
If the bases match, I'm just gonna write it once and combine the add the exponents. So it's following this rule here. If I have x to the m times x to the n, I write the base once and just add the exponents.
Wouldn't the 7a be negative?
It is.
It is, yeah, sorry. But it divides out to be positive still. Just had it look like it was part of the positive 7. Okay, number 8, we want to get that left side cleaned up. So let's bring everything down to base 3. 3 to the 5th power is 243. Okay. Okay, 9. Let's get all the bases to share 5. On dividing bases, I can subtract exponents. So 5 to the negative 9a, negative 9a minus 6a. Bases match, cancel them out. Negative 15a equals 3.
So you just subtract from top to the.
Yeah. Yeah, so this is applying this rule here. I have x to the m divided by x to the n, if the bases match and they're above each other, I can just write the base once and subtract the exponents. Okay, number 10, force everything to be a base 2. We bring this up about 1 or 2.
Yes.
I'm not open to it. Since we're young, like, it's hard to explain. Don't have a force to go.
Okay, number 11, base 4. Subtract the numerator denominator because they're above each other, they have the same base. Bases can go away. Okay, 30, 43, and 49, they both share a space of 7. And that 5 to 0 is just 1. I can force it to be 7 to the 0. I can still consider 1. Any questions? Yeah, let's just spend about 5 to 10 minutes starting the next section. 10.02. Okay, so I think we all feel pretty comfortable with exponents in terms of um, uh, visualizing it and understanding it. I think logarithms feel a little bit more difficult and abstract. So here's something to keep, I think, hopefully to focus our attention so that we can just not get thrown off by the fact that logs feel so weird. Okay, so logarithms. Or logs is the power that a number is raised, get some of the number. So it's a roundabout way of saying the exponent. So for instance, let me give you this example. 2 to the x equals 8. What is that x value? 3. Okay, so 3 is the logarithm. We can say this, the logarithm logarithm base 2 of 8 is 3. It's a roundabout way of saying solving for that exponent. Now, if it's a nice number that we can find, great, but if it's not a nice number, like 2 to the x equals 9, right? We know it's somewhere between 3 and 4, but logarithm allows us to find that exponent that otherwise would require a lot of guess and check. So logarithm is when you're trying to find the exponent, we're trying to isolate that exponent for exponential function. Right. Another way of saying it, logarithm function is the inverse of an exponential function. Let b and y be positive numbers, with b doesn't equal to 1. Then the logarithm of y with base b is denoted by log base b of y is denoted as the following. So if I were to switch the x and y and solve for y, I can go from exponential to log form. So for these examples, we're just going to practice isolating that that 3 by itself. So I can say 3 is equal to, or log base 2 of 8 is equal to 3. So I know that base 2 raised to what power is equal to 8? Base 2 raised to the third power is equal to 8. So I'm able to get that exponent by itself because that's what I want to represent as a log. So number 2, log base 5 of what? 1 over 125 is equal to -3. So when you do log form, you're basically extracting that exponent and putting it by itself and having a way of representing the other pieces on the other side. Okay, so number 3, log base 81 of 3 is equal to 4th. Okay. How about converting from log form to exponential form? The exponent is by itself, and now we want to put it back into exponent form. What's the base for number 4? Number 4. Yeah, 5 squared equals 25. Right, this we feel very comfortable with, but then just having to get used to that log form. But again, the log form is so that we can get that exponent by itself and have something that represents finding that exponent. Okay, number 5, base
7
7,
to the power negative 3 equals 1, 3, 3.
1 over 343. Okay, so again, we feel very comfortable with this. This feels weird, I know, but just understand that these are the same, and we just have to be able to go back and forth between them. Okay, last one here. Log base 32 of 2 equals 1/5. Same thing as saying 32 to the 1/5 is equal to 2. Okay, all right, great. We'll pick up tomorrow and continue component 2. Come get your phones.
Good, yes. Hey, please,